Welcome to today's video or today's class. Today we'll be looking at Lambert's W function. So I'm going to give you a very brief introduction to this Lambert W function and how it operates, and then we saw one or two examples on it. Okay. Another name for Lambert W function is also known as the product law function. It's a method of solving some equation numerically, because there are some equations that you cannot actually solve analytically except with the help of numerical approach, like the interruption iterative method, secant method, and the rest. But today we are looking at one aspect, which is the Lambert W function, which is also known as the product law function. The main concept behind this Lambert W function is this. Please note, in Lambert W function, when you have W of x exponential x, for instance, is always equals to x. Please take note of that. It also means that when you have something like W of, let's say, y squared, for instance, exponential y squared, it will just give you y squared. And of course, Lambert or W of, I think, let's say, for example, now lane x, exponential lane x. This one will give us what? Lane x. This is just the main secret behind this Lambert W function, which means if you are given a function, let's say x exponential x, that is a function that contains exponential that have the same power and the same letter at the back, then the product law function of that particular function gives you this particular number here. That is why I see this place also y squared with an exponential. So when you take the product law function, it gives you y squared. And of course, lane x, the same function here with an exponential. So if you take the product law function as well, then it will give you this lane x. So that is how this Lambert W function operates. So I'm going to take one sweet example to explain this, so that you understand what I'm trying to say. For instance, if x to power n is equals to n to power x, then find x. This is a very sweet sample. Normally, when you look at this critically, there is no way you'll be able to solve this analytically. But you can actually do this with the help of what? The Lambert W function. That is the beauty of Lambert W function. So let's look at this quickly. Solution to this. We have x to power n to be equals to n to power x. The first thing you do is you take the lane of both sides. You take the lane of both sides. And when you do that, it's going to give you lane x to power n to be equals to, I think, lane n to power x. Lane is still the same thing as log to base e. And according to one of the law of logarithm, when you have something like this, the n will come to the back of the logarithm. Also, the x here will also come to the back of the logarithm. It's a log in logarithm. So this gives us n lane x to be equals to x lane n. Okay, then the next step is you now look for a medium, or you develop a means of bringing all the x terms to this region and every other term to the other region. And for us to do that is you divide it by x as well as divide this side by x, so that this x will terminate this x, and then you are left with n lane x all over x here equals to lane n. This n2 have to come to this side. So what you do is you divide it by n, you also divide it by n. This n cancel this n, and you are left with lane x all over x equals to lane n all over n this way. And then from here, according to indices, which is called the negative index law, this is the same thing as x to power minus 1 lane x to be equals to lane n all over n this way. And then, of course, from here, I forgot to explain it here. There's another important stuff we need to take note of. Please note, exponential lane x is always equals to x. This is also very, very important. Okay? So, which means this x x to the power minus 1 is the same thing as exponential ln x to the power minus 1 and then ln x will be equal to ln n all over n. Because if you follow this rule here, remember that this is still the same thing as x to the power minus 1. So take note of that. It's a law in blockchain. Please take note. And then from here, this is the same thing as exponential minus ln x, then ln x here to be equal to ln n all over n this way. Wow. And then from here, this is the same thing as ln x exponential minus ln x is equal to ln n over n. And for us to make this place and this place the same, if you observe this place very well, there's a negative sign at the back of the lane. So we have to make this place and this place to be the same thing. So what we do now is we multiply through by minus. And when you do that, this becomes negative ln x exponential minus ln x is equals to minus ln n all over n this way. And then from here now you can now take the Lambert W function. So now taking the Lambert W function of both sides, you now have the product log function of minus ln x exponential minus ln x to be equals to the product log function of negative ln n all over n. And of course, according to what I've explained previously, the product log function of this now gives you negative ln x, which is now equals to the product log function of minus ln n all over n this way. Now, from here now, you take this minus to this region, so you have ln x equals to minus product log function of minus ln n all over n. And then from here now, this ln x, like I told you, is the same thing as log x to base e. So transforming logarithmic function into an indicial function, this gives us x to be equals to exponential minus product log function of minus ln n all over n. And when you solve this further, you discover that x is equals to n. Beautiful, right? So you see the beauty of the Lambert W function. It makes work easy. Naturally, you cannot solve this analytically, but with the help of Lambert W function, it's very easy. Thank you for watching my video, and please do well to always subscribe to my channel. Thank you.